Welcome back again, guys. We're still focusing on revision on probability. And remember to try at home. You try to do your mathematics with pen and paper. Observing only and not trying the problems might not be that helpful. But when you try to engage maths by trying the problem, that's actually the best way. Okay. So let's look at what we have our next question. Okay. So our next question, which is question 4. So a password consists of 5 different letters of the English alphabet. Okay, each letter may be used only once. Okay? So how many passwords can be formed? Okay? If what? If all letters of the alphabet can be used. Are we together? So we ask ourselves, how many alphabets do we have? So we have 26 alphabets from A to Z. So we want to create a password. What is the length of a password? Using 5 letters. Okay? So how many passwords can we get from that? So this is a counting principle. So we have to apply the fundamental principle of counting. So for a password of length 5, so for the first position, how many letters can we choose? How many letters do we have? We have 26. Okay? So, but do we have to repeat them? So it's very important that each letter may be used only once. So if the first letter I've used A, I can use A again. So this is a counting without repetition, because I cannot use the letter I've used in the first position or the one I've used in the second, and so on. So what does this mean? What does this look like? This is what we're going to have. Okay. So for the first position, we have 26 letters we can use. But we have already used one letter there. We only have 25 to use, because we cannot repeat. We can only use a letter once. If we have used 25, how many can we choose in that position? Only 24. If we have used 24, that position we can only use 23, and then is 22. So our answer here will be 26 times 25 times 24 times 23 times 22. You can leave your answer in that manner. That's okay. Or if you want, put that in your calculator and see how many ways are there. Are we all together? Very important that we cannot repeat our letters. Okay. Now let's look at the second question. What does the second question mean? So the same, we want to start a password. Okay, 5 different letters. Okay, so it implies this 1, 2, 3, 4, 5, something of that nature. But now the password must start with the letter D and end with the letter L. So it implies D will be there. L must be there. So what we have to worry about is that position and that position and that position. Are we together? So this is kind of like, so from our 26 letters, the password must start with D and also end with L. Can we repeat in between? No, it's still the same, because we can use the letter only once. So from 26 letters, we minus how many? 2 more letters, which is L and D, because our password must start with D or L. And this is what we get. So what it means, now we have 24 letters. Why 24 letters? Because our password starts with D and end with L. So from 26 letters, we can only use 24. So we have 24 there, which is that 24. Because we have 24 for that position now, this position, we have to use 23, because here we have 24 letters. we cannot repeat. We have 23, then follows by 22 letters. And what we do, we just multiply as indicated there. And that's fine. You can leave your answers 24 times 23, multiply by 22. Are we all together? Okay. Fantastic. Okay. Good. Let's look at the next one. Okay. So let's read our question again. 7 cars of different manufacturers. So we have 7 cars. Very important, there are 7 cars of different manufacturers, of which 3 are silver. Okay, what does that mean? If 3 are silver, that implies we have 4, which we don't know, okay? Because we have 7 cars. So 3 are silver are to be parked in a straight line. Are we all together? Now, in how many different ways can all cars be parked? Okay, interesting. So we have 7 cars, but from that 7 cars, 3 cars are silver, and we don't know about the 4, okay? So, but how many ways can we really park those 7 cars together, okay? So, this is counting without repetition, because if I've parked first car in the first position, then for the second parking spot, only 6 remaining cars can park. Then if I've parked the first and the second, then what happens there? Let's look at this. So because we have 7 cars, which is 1, 2, 3, 4, 6, 7. So it's 1, 2, 3, 4, 5, 6, 7 cars. So if I park the first car there, okay, which is car number, I take 1 car. So the first car has 7, can choose as the first car where to go. You can go there, or there, or there, or there, or there as the first car. So you have 7 choices as the first car. The first car to arrive has 7 choices. So the first spot has been taken. The next car has how many choices left? If you look at that, the next car has 6 choices, which will be 6. So then the next car, so that spot has been taken. The next car will have what? 5. Then what about the next car? The next car will have 4. Then the next will have 3. Then 2. Then the last car will have only 1 choice because the rest will be taken. So then to answer our question, we just have to multiply all those choices. And what do we get? We get 7. So we get 7. So it would be 7 times 6 times 5 times 4 times 3 times 2 times 1. And you can put that on your calculator. But this is fine like that without simplifying the answer. Okay. It's actually better because if you've typed the answer, you've put your answer on a calculator and give me a number, and what if your number is wrong? Then we're not sure whether you understand. But if you write your answer like that, if you made an error, you're able to get some of the marks. Okay, you show that you understand that. Are we all together? Now, let's look at the second question. So it's still the same question where we have 7 cars, okay, of different manufacturers. 3 is still silver. Are we all together? Are to be parked on a straight line. Okay, now, if 3 silver cars must be parked next to each other, determine how many different ways the car must be parked. Okay, So now, what is this asking is that the silver cars must be parked next to each other. So it implies the silver cars must be, you must have silver, 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 and the rest of the cars. Are we all together? Okay? So I can have silver, silver, and doesn't matter on the sides, or I can have 3 silvers in the beginning and doesn't matter the other 4. So, but the 3 silver must be packed together. So what do we have to do with this question? We're going to apply the fundamental principle of counting, which states that if I have m ways of doing something and n way of doing something, then the total ways of doing that will be m times n. Are we together? So we're going to look at how many ways can we park those silver cars, which there's 3 silver, and other cars which are 4s, and how many ways can we park them? Then multiply that. Then that will give us how many different ways that the car can be parked. So for silver cars, we know this 1, 2, 3 cars. And the rest we have 1, 2, 3, 4 cars, because we have 7 cars. Are we together? So to do that, we're going to look at this. So for silver cars, we have 3 times 2 times 1. Are we together? And for other cars, it's 4 times 3 times 2 times 1. And you just multiply that. And that will give us the total ways. Are we all together? Okay, fantastic. Put that in your calculator and you get the answer. Or you can leave it like that. Fantastic. I hope this makes sense. And we'll come back and look at more problems after this break.